All right, welcome to this technical explainer. If you're a procurement manager, a technical director, or an R&D engineer operating in the absolute highest tiers of advanced manufacturing, you are exactly in the right place today. We're taking a definitive, engineering-driven look at advanced material solutions, specifically focusing on the non-standard ultra-precision tungsten carbide customization capabilities brought to the table by Evergreen Carbide. Look, we aren't talking about basic hobbyist tools here, okay? We're diving into the foundational engineering required to maintain structural integrity in literally the most demanding manufacturing environments on the planet. We're talking aerospace, medical device manufacturing, and high-wear mining operations. So, let's get right into it.
Okay, let's dive into this. Our technical briefing today is structured into 4 quick, distinct segments. First, the customization necessity. Second, engineering the solution. Third, our exclusive product showcase. And fourth, an actionable closing. Let's get started. Segment 1, the customization necessity, where we look at overcoming standard tooling limitations.
Now, we have to talk about the absolute, non-negotiable reality of modern manufacturing, and that is tight tolerances. In sectors like aerospace, mining, or medical engineering, we're not just dealing with a minor inconvenience when a tool wears out prematurely. We are talking about the catastrophic costs of tooling failure. I mean, think about it. A deviation of just a few microns, that can mean a scrapped turbine blade, a failed medical implant, or severe structural failure in heavy mining equipment. Which brings us to a really provocative question. Are your current cutting tools actually built to withstand the demands of next-generation manufacturing? It's a serious question, because what we're seeing in the data is that standard, off-the-shelf tools are simply buckling under the pressure of multi-axis stress, aggressive feed rates, and extreme thermal loads. If you're out there machining superalloys or hardened steel, standard tooling is effectively a bottleneck in your entire production line.
Think about those standard tooling limitations for a second. You get rapid wear, thermal instability, and these rigid, inflexible geometries. When you push those standard tools to the absolute limit, they deform, they lose their edge, and ultimately, they destroy your workpiece. Now contrast that with the shift to advanced carbide solutions, like those from a manufacturer like Evergreen. We're talking about extreme wear resistance, ultra-high temperature stability, and most importantly here, custom geometries tailored to your exact machining application. The return on investment with this stuff isn't just in the tool lasting longer. It's in the preserved structural integrity of your million-dollar components and the massive reduction in machine downtime.
Moving right along to segment 2, engineering the solution, the core of precision.
So you might be wondering, how do we actually achieve that extreme wear resistance? Well, it all comes down to the underlying engineering capabilities and incredibly strict process controls. Evergreen Carbide's ISO 9001-2008 certified manufacturing processes guarantee the high purity and the extreme precision required to solve these incredibly complex geometry challenges. There's a quote directly from the engineering documentation that I think sums it up perfectly. Carbide rods, the backbone of precision and durability for industrial applications. I mean, everything starts right here. Before you even have a highly complex multi-flute end mill, you have a tungsten carbide rod. The metallurgical purity of this rod, specifically how those tungsten carbide grains are sintered with the cobalt binder, that literally determines whether your tool is going to shatter under load or slice through hardened steel like it's butter.
Now, what's really interesting here is the engineering divergence right at the very base level of tool creation. You have solid carbide rods, right? These provide maximum core strength and traditional rigidity. They are absolutely ideal for heavy-duty roughing where massive shear force is applied. But then consider hollow carbide rods. These are explicitly engineered with internal channels. Why? Well, because in deep-hole drilling or high-speed machining, heat is your absolute worst enemy. Those hollow channels allow for internal coolant capabilities, which means you're blasting fluid directly to the cutting edge, dynamically managing that thermal expansion, and getting some really specific structural and weight advantages in the process.
But what happens when tungsten carbide alone isn't quite enough for the most extreme environments? Well, material science gives us PCBN. That stands for polycrystalline cubic boron nitride, second only to diamond in hardness, folks. These inserts are engineered specifically for extreme temperature stability. If you're turning or milling highly hardened materials, think automotive drive shafts or intense aerospace engine components, PCBN is what allows you to maintain those aggressive cutting speeds without the insert chemically reacting with the ferrous metals at ultra-high temperatures. It is pure, hard science applied directly to manufacturing. Because let's be honest here, machining these kinds of metals with standard tools will melt your insert before your operator can even hit the E-stop.
All right, on to segment 3. Our exclusive product showcase, highlighting high-tech machining capabilities.
For all the technical directors tuning in right now, we're about to pull back the curtain and examine the specific performance specifications of these specialized custom solutions. So, the crucial point here is this number, HRC 65. That is an ultra-high hardness threshold on the Rockwell scale. Machining a workpiece that is HRC 65 is incredibly difficult. It literally destroys lesser tools instantly. But Evergreen produces premium tungsten steel ball nose and end mills specifically rated to not just survive, but to actively profile and machine materials at this extreme hardness. This right here, this is the exact definition of elite tooling.
Let's break down exactly how they achieve this by looking at their end mills. It's like a perfectly engineered puzzle where the geometry flawlessly marries the coating. Take a square end mill doing heavy work, for example. They utilize AlTIN or TISN coatings. That's aluminum titanium nitride, which actually forms a protective aluminum oxide layer under high heat, giving you extreme wear resistance. Then, for aluminum end mills, they use DLC, diamond-like carbon, or just leave them uncoated. Why? Because aluminum is notoriously sticky and causes chip welding, and DLC prevents that entirely. And for ball nose end mills doing complex 3D contouring on hardened molds, their nano blue coating provides just incredible lubricity and heat resistance. Whether it's a 2, 3, or 4 flute design, every single aspect of this engineering is completely intentional.
And that exact same intentionality applies to their advanced precision drilling solutions too. Let's do a rapid-fire look at the data here. We're talking about high-precision 3D, 5D, and 8D drills. To put that into perspective, that means they can drill depths up to 8 times the tool's diameter with absolutely flawless runout. We've got indexable crown drill bits for super efficient CNC machining, tungsten carbide micro-diameter drills for medical applications where precision is literally measured under a microscope, and solid carbide step drills that brilliantly combine multiple operations into a single plunge. Oh, and the same level of ultra-precision is also applied to their custom high-precision wire drawing dies, designed specifically for extreme wear resistance in continuous manufacturing setups. It's a real game changer.
And this next part brilliantly illustrates their dominance in custom indexable tooling. You have WCMX U-drill inserts featuring these unique, colorful coatings engineered for notoriously difficult, work-hardening aerospace alloys like nickel and chromium. But, it doesn't even stop at cutting. Evergreen also engineers advanced weldable alloys designed specifically for highly reliable structural joining in the absolute harshest environments imaginable. Add in the MGMN series groove inserts, which utilize targeted CVD and PVD coatings to handle the brutal, interrupted cuts of tempered and stainless steel, along with highly precise NPT and BSPT threading configurations, and you have a completely customized arsenal at your disposal.
Finally, Segment 4, an actionable closing. Let's talk about partnering for precision. So we've looked at the science, we've talked about the necessity, and we've gone through the hardcore specifications. Now it's about shifting from simply understanding this elite technology to actually implementing it within your own procurement and R&D pipelines. If you are ready to secure your manufacturing tolerances for good and eliminate the bottlenecks caused by inadequate tooling, you need to initiate a direct technical consultation. Head over to www.evergreencarbide.com. Review their full range of custom carbide solutions, from those precision-engineered rods we talked about to the specialized weldable alloys, and partner with engineers who truly understand that your production lines simply cannot compromise on quality. So, I want to leave you by returning to that provocative thought we started with today. Are your current cutting tools truly built to withstand the demands of next-generation manufacturing? Because if there is even a shadow of a doubt in your mind right now, then your current material engineering standards are holding you back. Period. It is time to upgrade. Thank you so much for joining me for this briefing, and keep pushing the boundaries of what's possible in manufacturing. Catch you next time.